Good morning, students. Our topic is applications in optimization. So, optimization is a process of finding an extreme value, that is maximum or minimum value under certain conditions. Okay, so we have learned how to find the extreme values, that is local maximum and local minimum, using first derivative test and second derivative test. So, here exercise 7.8, the problems in exercise 7.8, we are going to do using second derivative test to solve it. Okay, so I'll take the first problem in exercise 7.8. Find two positive numbers whose sum is 12 and their product is maximum. You have to read the question carefully. Find two positive numbers whose sum is 12 and their product is maximum. So here in this problem, we have to find two positive numbers. Sum of those two positive numbers is 12 and the product of the numbers should be maximum. Okay, so satisfying these two conditions. Okay, what is the condition? The sum should be 12. Okay, sum is given to you. And the product of those two numbers, maximum, you have to find the two positive numbers. So, in this problem, one result is given. What result is given? Sum of those two numbers is 12. So, I'll take the positive numbers be x and y. What is given that? The sum is 12. So, how you can write? X plus y is equal to 12. So, from the given result, you have to write one variable in terms of other. So, here I have written y is equal to 12 minus x. So, the first step of this exercise 7.8, you have to take the given result. So, you have to write the one variable in terms of other from the given result. And see that what is next, you have to search which result should be maximum or minimum. So, in this problem, their product is maximum. So, what is the product of those two numbers? X into y. So, I have written this is equal to product. Here, in the place of y, I am going to substitute 12 minus x. So, x into 12 minus x, when you simplify, it is 12x minus x squared. You look at this. Here, no y is involved. So, it's a function of x. So, I have denoted as f of x. What is f of x now? It's a product of two numbers. So, the product should be maximum in this problem. So, first I have taken the product of those two numbers is xy. So, here y has to be substituted in terms of x. So, the product is a function of x now. Okay, so I have taken as f of x. So, it should be maximum. So, how to write the maximum value using the second derivative test? You see that the steps. You have to find the first derivative, then equate first derivative is equal to 0, find points, and you have to find the second derivative, substitute the points which is obtained by equating the first derivative is equal to 0. First derivative equate panni when the points you have to substitute in the second derivative. So, the second derivative is less than 0 means the function is maximum at that point. If the second derivative is greater than 0 means the function is minimum at the point. That is the procedure. Okay. So, here f of x. So, I am going for the first derivative. So, I have to differentiate 12x minus x squared with respect to x. The differentiation of 12x is 12. 12 is a constant. The differentiation of x is 1. So, the answer is 12. Next, minus x squared. If you differentiate, that is 2x. What will be the next step? You have to equate f dash of x is equal to 0. So, 12 minus 2x is equal to 0. 12 is equal to 2x. X is equal to 6. So if you obtain directly, you should not find y, because what is the condition is given, the product should be maximum. So here we have to proceed to show the product is maximum. So we have found the point, that is x is equal to 6. What's the next step? So we have to go for the second derivative. So go to the first derivative, it is 12 minus 2x. So the differentiation of 12 is 0. And minus 2x, if you differentiate, minus 2 is a constant. The differentiation of x is 1. So you are getting minus 2. Okay. So what we have to do next step? The point has to be substituted in the second derivative. What is the point we have obtained? 6. So 6 has to be substituted here. So here it is minus 2 is a constant. So whatever you substitute for x, it will be minus 2. So see the second derivative. After substituting the point, it is less than 0. The second derivative at the point is less than 0 means the function is, what is it? Maximum. What is the function here? F of x. So f of x, what we have denoted, it's a product. So we have shown the product is maximum when x is equal to 6. Okay, so I have written the product is maximum at x is equal to 6. Here we have shown that the product is maximum. Okay, what is asked? Find the two positive numbers. So x we have found. Next you have to find y. So what is y relation? Y is equal to, we have written 12 minus x. So it is 12 minus 6, that is equal to, y is equal to 6. So the two positive numbers are 6 and 6. Okay, so we'll go to the second problem. Find two positive numbers whose product is 20 and their sum is minimum. You see that just opposite to the previous problem. What is given here? The product is 20. Okay, so as usual, let the two positive numbers be x and y. What is the given result? Product is 20. So xy is equal to 20. What I said, from the given result, you have to write one variable in terms of other. So y is equal to 20 by x. Next, you have to see which should be minimum or maximum. So in this problem, their sum is minimum. So you are going to find the sum. Sum of those two numbers is x plus y. What you have to do? You have to make it as a single variable. So in the place of y, you have to substitute 20 by x. The whole thing is a function of x. So we have to take this as f of x. Now in your problem, what is your f of x? That is sum. Okay, sum, what we have to show? It should be maximum. So we have to use the procedure. So second derivative test to find the minimum sum. So for that you have to find the first derivative. So the differentiation of x is 1. And here 20 is a constant. Here 1 by x. What is the differentiation of 1 by x? Minus 1 by x square. So it will come minus 20 by x square. What's the second step? You have to equate to 0. So when you equate to 0, it is 1 minus 20 by x squared is equal to 0. So 1 is equal to 20 by x squared. So when you cross multiply, x squared is equal to 20. X is equal to plus or minus square root of 20. The square root of 20 can be written as 4 into 5. Square root of 4 is 2. So it is 2 root 5. So I have written x is equal to plus or minus 2 root 5. So x, only the positive numbers. So we are not going to consider the negative values. So x is equal to 2 root 5. Okay, we didn't show it. The sum is minimum. So for that you have to go for the second derivative. So what is the first derivative we have found? It is 1 minus 20 by x squared. What is the differentiation of 1? It is 0. Here minus 20 is a constant. 1 by x squared. Okay, the differentiation of 1 by x squared is, what is it? It is 2 by x cubed. You see that? Differentiation of what is it? It is minus 20 by x squared. Okay, listen now. Minus 20 is a constant. Now what you are having? 1 by x squared. So 1 by x squared is in the denominator. When you take it to the numerator, it will be x power minus 2. What is the differentiation of x power minus 2? It is x power minus 2 plus 1 divided by sorry ma'am, it's a differentiation, x power minus 2. So x power minus 2, the differentiation is, what is it, minus 20 is a constant. How to n x power n minus 1. So that is minus 2 into x power minus 3. So minus 20 into minus 2. So minus into minus plus. So I have written 20 into 2. So x power minus 3 can be written as 1 by x cube. So it is 40 by x cube, isn't it? Okay. So what you have to do, x value has to be substituted in the second derivative. When you substitute, it is 2 root 5 the whole cube. So we have to check whether it is positive or negative. So see that it is greater than 0. The second derivative at the point is greater than 0 means the function is minimum. So what is the function we have taken? F of x. F of x is considered as sum. So sum is minimum when x is equal to 2 root 5. Okay, next what you have to find? The two numbers you have to find. So we have to go for y. What is y? 20 by x. Okay, so 20 by 2 root 5. So the 2 and 20 getting cancelled, 10 by root 5. So multiply and divided by root 5. It is 10 root 5 divided by root 5 into root 5 is 5. 5 and 10 getting cancelled. It is 2 root 5. So the two positive numbers are 2 root 5 and 2 root 5. Okay. So we'll go to the problem number 3 now. Okay. See that. Find the smallest possible value of x squared plus y squared given that x plus y is equal to 10. So what is asked? Find the smallest possible value of x squared plus y squared given that x plus y is equal to 10. So here we need not declare the variable. Already it is given in terms of x and y. So first you take the given result. What is the given result? X plus y is equal to 10. From that what you have to do? You have to write one variable in terms of other. So I have written y is equal to 10 minus x. Next you have to search which should be maximum or minimum. Which result should be maximum or minimum in that problem. See the question. Find the smallest possible value of x squared plus y squared. So x squared plus y squared order smallest value we have to find out. So you consider x squared plus y squared. Okay, that term you just consider. In that, in the place of y you have to substitute 10 minus x. So y squared means 10 minus x the whole square. So now it is fully in terms of x. So you denote it as f of x. Okay, it is denoted by f of x. So we can, next we have to go for the second derivative test. So for that you just arrange this function. It is in the form of a minus b the whole squared. So a squared is 100 plus b squared is x squared minus 2ab. So minus 2 into 10, 20 x. So this is your f of x. So x squared plus x squared is 2x squared minus 20x plus 100. So this function, what we have to prove that it is minimum. So for that we are going to use the second derivative test. So the first step you have to differentiate f of x. So that is f dash of x. 2 is a constant. X square differentiation is 2x minus 20x. Minus 20 is a constant. The differentiation of x is 1. The differentiation of 100 is 0. So it can be written as 4x minus 20. What's the next step? You have to equate the first derivative to 0. So 4x minus 20 is equal to 0. 4x is equal to 20. X is equal to 5. After finding this point, so you have to find the second derivative. So it's a first derivative. So you have to differentiate f dash of x with respect to x, that is f double dash of x. So 4x, when you differentiate, 4 is a constant. The differentiation of x is 1. So it is 4. Minus 20 is a constant whose differentiation is 0. Next, you have to substitute this point which is obtained by equating f dash of x is equal to 0. That point has to be substituted in f double dash of x. So it will be, that is also 4, because it's a constant, it will not vary. So 4. How is your 4? It is greater than 0. If it is greater than 0 means the function is, what is it? Minimum. What is the function? F of x. F of x denotes what? X squared plus y squared. So I have written x squared plus y squared is minimum when x is equal to 5. So what is asked? what is the smallest value of x squared plus y squared. So x is there, so we have to find y. So using this relation, find y. Y is equal to 10 minus 5, that is equal to 5. So x and y is not asked. The smallest possible value of x squared plus y squared. So the smallest possible value of x squared plus y squared is equal to x. In the place of x, you have to substitute 5. So 5 squared. Y also 5. So 5 squared. That is 25 plus 25. That is equal to 50. Okay. Now see the fourth problem. A garden is to be laid out in a rectangular area and protected by wire fence. Okay. So the garden in a shape la irukku, it is in the rectangular shape and it is the garden. So what is it? So the garden is fenced by the wire. Okay. So you see the question. What is the largest possible area of the fenced garden with 40 meters of wide? What is asked? What is the largest possible area of the garden? The garden is fenced with 40 meters of wire. So it's a rectangular garden. So I have taken a rectangular. So with rectangular you will have two dimensions. One is x, another one is y. So let x and y be the dimensions of the rectangular garden. Okay. So what I have said usually, so you have to take the given result. What is the result is given? You see that 40 meters of wire. So 40 meters of wire is used to fence the garden. So if you want to fence the garden, you will, where we have to fence? So from starting from here to here. So the whole thing has to be fenced. We will not fence in between. Okay. So it is nothing but the 40 meters wire is used to fence the perimeter of the rectangular garden. So see that, given that 40 meters of wire is used to fence the garden. So the length of wire used is 40 meters. So that is representing the perimeter of the rectangle. Okay. What is the perimeter of the rectangle? It is 2x plus 2y. X plus y plus x plus y. That is 2x plus 2y. You know the formula very well. So 2 into x plus y is equal to 40. So x plus y is equal to 40 by 2, that is 20. So from the given result, what we have to do? We have to write one variable in terms of other. So I have written y is equal to 20 minus x. So one step is over. Next, what I said, you have to find out which should be maximum or minimum. You see the word largest possible area of the fenced garden. So we have to find the area of the rectangular garden should be maximum. So you have to take the area of the rectangle. So what is the area of the rectangle? Length into breadth. So here we have taken x into y. So what you have to do? In the place of y, you have to substitute 20 minus x. So previous result we have found y is equal to 20 minus x. That has to be substituted here and just multiply. X into 20 is 20x minus x square. So it is a function of x. So we have to denote as f of x. Now what is f of x represented? It is the area of the rectangular garden. So that area we have to find out maximum. Okay, so for that we have to use the second derivative test. For that the first step is you have to differentiate f of x with respect to x. So f dash of x, that is equal to, if you differentiate 20x, the answer is 20. X squared differentiation is 2x. So 20 minus 2x. The next step is what? You have to equate f dash of x is equal to 0. So 20 minus 2x is equal to 0. So 2x is equal to 20. So x is equal to 10. Next step, you have to find the second derivative. Go to the first derivative, differentiate with respect to x again. 20 differentiation is 0. Minus 2x, if you differentiate, minus 2 is a constant. The differentiation of x is 1. So therefore this is f double dash of x. Next step, what do you have to do? Substitute this point in the second derivative. So f double dash of 10, that also minus 2. What is minus 2? It is less than 0. The second derivative at that point is less than 0. The function is maximum. Here, what is your f of x? That is the area. So, area of the rectangular garden is maximum when x is equal to 10. What is asked? What is the largest possible area? So, to find area, we need y. So, what is the relation in terms of y? Y is equal to 20 minus x. So, 20 minus 10, that is equal to 10. So, here it is asked as largest possible area of the rectangular garden, that is x into y. So your x is 10 and your y also 10, so that is equal to 100 square meter. Okay, come to the sixth problem. A farmer plans to fence a rectangular pasture adjacent to a river. So here I have shown the river. Just adjacent to it you will have a rectangular pasture. Pasture it's a pulvey. Okay, the pasture must contain 1,80,000 square meters in order to provide enough grass for herds. The herds is nothing but the group of sheep, that is Aattu Mandai. Okay, so the pasture, the pulvey must contain 1,80,000 square meters. Okay, so the 1,80,000 is representing the area of the pasture. The pasture in which shape? It is in the rectangular shape. So I have taken the rectangular. One side you will have the river. So this is x and here this is y. So let x and y be the dimensions of the rectangular pasture. Okay, so here what we have to usually we will do, we will take the given result. What is the result is given? 1,80,000. So 1,80,000 is what? It is the area of the pasture. Okay, so area is equal to 1,80,000. It is in the rectangular shape, so it is xy is equal to 1,80,000. So what do you have to do? From that you have to find y is equal to 1,80,000 by x. What is the next step? You have to find out which should be maximum or minimum. See the next sentence. No fencing is needed along the river. We are not going to fence in the river side. Okay. What is the next question? What is the length of the minimum needed fencing material? So now we have to fence the pasture using some material. So we are going to find what is the minimum needed fencing material length. That is nothing but, so where we are going to fence? So starting from here to this part and here, we are not going to fence along the river. So it is nothing but to fence the garden we have to use the perimeter. So here x plus y plus y. So that is x plus, what is it here? X plus 2y. Okay, consider x plus 2y. This is the length we have to fence it. So here x and y. So in the place of y, what you have to substitute? 1,80,000 by x. Okay, so fully it is in terms of x. So we have to take this as f of x. F of x is what now? What is it? It's a length of the, what is it? It is the length to fence. Okay. So that is f of x. So it should be minimum. We have to find the length, minimum length of the wire. So you have to differentiate it. So f dash of x. So x, the differentiation of x is 1. Okay, here 2 into 1,80,000 is a constant. So here you are having 1 by x. The differentiation of 1 by x is minus 1 by x squared. So I have written the constant as it is. Next step, what it is? F dash of x is equal to 0. So when you equate to 0, so this term 2 into 1,80,000 is, it is 3,60,000. Okay, divided by x square. So when you cross multiply, x squared is equal to 3,60,000. So x is equal to plus or minus square root of that. So 36, it is nothing but 6. So here for these two zeros, so when you take square, it is nothing but 600. Okay, plus or minus 600. So x is the length, it cannot be negative. So it is not possible. So we'll take x is equal to 600. Okay, so what you have to do here? So x is equal to 600. Next you have to find out f double dash of x. So go to f dash of x. Here you are having 1 minus 2 into 1,80,000 divided by x square. So the differentiation of 1 is 0. Here minus 2 into 1,80,000 is a constant. This x squared, when you take it to the numerator, it is x power minus 2. The differentiation of x power minus 2 is minus 2 into x power minus 3. So minus into minus will become plus here. So you are getting 2 into 1,80,000 into 2 divided by x cube. Okay, so what you have to do, this x is equal to 600 has to be substituted in f double dash of 600. Okay, so in the place of x you have to substitute 600. So in the place of x cube you have to write 600 the whole cube. You need not calculate the value. So how it is? It is greater than 0. The second derivative at any point is greater than 0 means the function is minimum. So which is your f of x? So that is x plus 2y. So that value is minimum when x is equal to 600. Next what you have to find? Y. So y is equal to 1,80,000 divided by x. So x is equal to 600. When you cancel, it is 300. Okay. So what is asked? What is the minimum length of the fencing material? So what is the minimum length? So x plus 2y. So when x is equal to 600 and in the place of y you have to substitute 300. So 2 into 300 is 600. So the length of the length to be fenced is 1200 meter. That is the minimum length of the fencing material is 1200 meter. Thank you, students.